All right, so this is part C of section 13.3, and we're going to talk about double replacement and combustion reactions. First of all, double replacement. In double replacement, we have two reactants, and what happens is they exchange cations. They change partners. So the key we're looking for is two compounds as reactants and two compounds as products. Here's some clues that when you do this in the lab that you've got the reaction actually taking place. One, you might see a precipitate form. That would be that solid that falls out of solution there. Second, you might see some bubbles. You put it together and you see bubbles. You see gases given off like hydrogen or something like that. And the third thing is a molecular compound is produced. Now you can't always see that, but you can, with an equation, figure out that water, that's a molecular compound is produced. Otherwise, if none of these compounds, if you don't have a precipitate formed or something like that, these reactions, just nothing happens. You put them together and nothing is going to take place. So one of these things has to happen in order for the reaction to actually take place. So let's take a look at an example. Silver nitrate. So you got some silver nitrate. This is a clear solution. You've got some sodium chloride. That would be a clear solution. And notice that when you put it together, what happens is the silver takes out the sodium here. It kicks out. These guys trade places. And we get silver chloride. Now, silver chloride does not dissolve in water. So when you mix these two together in the silver ions, because when you put things in water, they ionize. When they say they're aqueous, it means we're going to see a lot of Ag pluses, and we're going to get a lot of NO3 minuses, and sodium ions, and chloride ions. We get all those things running around in solution, but when these two guys meet, they form something that does not dissolve. And so all of a sudden you get this white precipitate. This is still running around as ions. It's still in there. Doesn't really do much. Okay, so this is one example. Here's another example. Once again, notice that our sodium is going to replace hydrogen here. Hydrogen is going to come over here. And notice that you don't get like H2OH, you get H2O. That's the compound that's formed, but the hydrogen is joining with that polyatomic ion, the hydroxide ion. The sodium is joining with the sulfate ion in this particular reaction. And here's another one. If we're trying to figure this out, let's figure out what's going to happen. Remember, we're going to try to switch these guys. So the lead's going to take the place of sodium. Sodium's going to come over here. So we're going to put lead and iodine together. And lead is a 2 plus. Iodine's a 1 minus. So we get this PbI2. And this is the one that's a precipitate. This would be a yellowish compound. And then our other thing is going to be sodium and nitrate is NO3 minus, sodium is Na plus, so it's just going to be NaNO3. And you have to put them back together. You've got to think about what those charges are when you put them back together. And then you got to go back and say, okay, now we need to balance this equation. So let's take a look. Looks like we've got two I's over on the right, so we better put a 2 there. That kind of means this needs to be a 2. And I think we're good at that point. All right, so why don't you see if you can do these two equations here. So stop the video and do these on paper. Okay, so once again on this one, you're going to get that silver chloride. Remember, silver's a +1, silver's Ag+, chloride's -1. And our other thing is NaNO3. You're starting to see some kind of similar common compounds that we get here. If we look at the next one, we've got Fe, and if you want to figure out, well, what's the charge, kind of reverse that. See, that's a 3, so that's what that would be up here. So this is an Fe3+, and we've got our hydroxide, which is a 1 minus. So we're going to get FeOH3, and we're going to get potassium, which is plus, chlorine, which is minus, KCl. And make sure that you put it back in the right order. A lot of times people try to put it in, they put the Cl before the K, and you wouldn't do that. It's always the cation first, then the anion. Now, go back and balance this equation. So, looks like I need to put a 3 there to balance my chlorines. And it looks like I need to put a 3 there to balance those. Alright, so let's go to the last one. The last one is known as combustion reactions. In combustion, we've got something that's going to react with oxygen and produce carbon dioxide and water. Quite often, what we're using is something called a hydrocarbon, which is simply carbon and hydrogen. Those are very familiar things. We've already talked about some things like that. CH4 is methane. Octane, which is what we use in gasoline, is C8H18. These are just real common hydrocarbons, and these things tend to burn really well. They give you carbon dioxide and water when you're done. So, whatever that hydrocarbon is plus oxygen gives you CO2 plus H2O. This is what's known as a complete combustion reaction. Complete meaning there was plenty of oxygen and we get the carbon dioxide. And we'll talk about incomplete here in just a little bit. So, if we have, this is octane here, we talked about C8H18. And this is one of those that notice that you had to double this. If you were to work your way through this problem when you first did it, if you're trying to balance the carbons, you would say, well, there should be 8 there. And you're balancing the the hydrogens, and you'd put a 9 here. But what you'd find out is you've got 16 oxygens here and 9 oxygens there, so a total of 25 oxygens. Well, when you got O2s, you can't get an odd number, so you have to double everything. So you put a 2 there. You can put the 25 here now. This becomes 16. This one becomes 18. This happens half the time, because half the time you come out with an odd number for oxygen. When you come out with an odd number for oxygen, you have to double it because oxygen is always O2. So just expect this. Alright, so we talked about complete combustion, we get CO2 and water. If we get incomplete combustion, we get carbon monoxide and water. So if there's not enough oxygen around to burn this completely, you get carbon monoxide, which is not a good thing. Carbon monoxide is a poisonous gas. If there's carbon monoxide, your blood will take the carbon monoxide before it takes the oxygen. And so what happens is you just don't get any oxygen. Even though there might be oxygen in the room, your body wants to take that carbon monoxide over the oxygen. So kind of bad stuff. All right, so take a look at these, and I want you to identify them as complete or incomplete. Okay, so take a look at those and decide if they're complete or incomplete. Alright, so if we're looking for complete ones, we're looking for carbon dioxide. So those are complete right there. Those 3 are complete. Okay, the other ones are the incompletes because they have carbon monoxide. So all you got to do, look for which one, if carbon monoxide, carbon dioxide. As far as balancing, the same thing's going to happen. They didn't balance these because I'm going to have you balance them here in just a little bit. But the same thing happens. Half time you got to double, and half time you don't. All right, why don't you just balance these 2? Work on balancing these 2. So stop the video, see if you can balance these. All right, so on the first one, we're going to try to balance. We're going to put a 5 here, balance the carbons. We need 12, so we'll put a 6 here. That looks good. So we've got 5 times 2 is 10 oxygen, 6 times 1 is 6. So we got 16 oxygens, so we need an 8 here. This is one that you didn't have to double. Okay, looking at the second one, let's put a 2 here. And we need 6, so we'll put a 3 here. If we want to count oxygens now, we got 2 plus 3, and we got 5. And once again, anytime you get an odd number, this is a clue. Well, it's not a clue, it's just this is what happens. It does it, okay? So now you got to double. Okay, so that makes this, so take this out, take that out, make this a 4, make this a 6 now. And so now I've got 10 oxygens, and so this can be a 5. And then when you're done, this is always going to be the odd number, and all the other ones are going to be even when you're done balancing. All right, so that's the end of section 3. Lots of different types of reactions, and you'll need to be able to identify, just looking at the reaction, which of those 5 types they are. You'll also need to be able to balance the equations, and if I only give you part of the reaction, you need to finish the reaction. Those are the kind of things that you need to be able to do out of that section.